welcome to Lab 3 Part 2, where we will program the false position method. Here we have the definition for false position. We will see that the code for the false position method is very similar to the bisection method, with the key exception of xi. As always, we will start by importing the libraries. We will need NumPy, as well as pandas for displaying our tables. Then we will declare a helper function called falsePosition2, which will return the results of step 2. For the inputs, we need f, the function, and the interval a and b, then a colon. Next, let's take a look at the formula for xi, and we must translate this into code. So to do this, we will use xi equal to a times f at b minus b times f at a, all divided by f at b minus f at a. Now let's take a look at step 1, which says to evaluate fa and fb to ensure that fa times fb is less than 0, otherwise exit with an error. So this will be our first condition. If f at a times f at b is greater than 0, then we will return a list with the values xi, a, b, and the message root not bracketed. Our next condition is the first line in step 2, which states that if f at xi is equal to 0, then the root has been found and the value of the error is 0. So we will use an elif f at xi is equal to 0, in which case we will return the values xi, a, b, and the message root found. Now on to the next condition in step 2, which states that if f at xi times f at a is less than 0, then for the next iteration, xi plus 1 is bracketed between a and xi. So here we will say elif f at xi times f at a is less than 0, then return xi, a, xi, and the message root between a and xi. Our last condition in step 2 says that if f at xi times f at b is less than 0, then for the next iteration xi plus 1 is bracketed between xi and b. So here we will say elif f at xi times f at b is less than 0, then we will return xi, xi, b, and the message root between xi and b. Now we will move on to our main function, which we will call false position, and pass in the function f, the interval a, b, the max number of iterations, and the stopping error. Next, we will initialize our tables, the first being error table, which will start with 1, our error note table, which will be empty. Our A table will start with A, our B table will start with B, our X table will be empty, our stop code will be no stopping, and I will start with 0. Now onto our while loop, which will keep looping while I is less than or equal to nmax, and the stop code is equal to no stopping. Then a colon. We will start our while loop by calling our helper function and set it equal to ri, which will be equal to false position 2, and we will pass in f, a table at I, and then b table at I. Now that we have ri as the returned list for my helper function, we will start by extracting the message at index 3. So if our message, which is ri at index 3, is equal to our first message, which is root not bracketed, then we must append to the x table the value of ri at index 0, and we will append to our error note table the value at ri at index 3. And finally, we will break out of a while loop. Our next condition is if ri at 3 is equal to our second message, which is root found. Now if we go back to our definition, if the root is found, then we must set the error to 0 and exit. So let's start by appending to the x table the value of Ri at 0. Then we must append an error of 0 to our error table. And like before, we must append our method to our error note table. And finally, we must break out of the while loop. This leaves us with the last two conditions in our step 2, which we will perform the same action for both. So we do not need an if statement in this case. And for both, we must append to our A table Ri at 1. We must append to our B table Ri at 2. We must append to our x table Ri at 0. And we must append to our error note table Ri at 3. Now we will move on to calculating our error. To do this, we must first check that I is not equal to 0, in which case we will set ei, our error at this iteration, equal to x table at I minus x table at I minus 1, or divided by x table at I. Then we'll go ahead and append the value of ei. Moving on to step 3, which states that if I reaches the maximum number of iterations, or if epsilon r is less than or equal to epsilon s, then the iterations are stopped. Otherwise, return to step 2. To check if epsilon r is less than or equal to epsilon s, we can declare if statement where the absolute value of error table at I must be greater than EPS in order for us to keep looping. And we will indicate this by setting our stop code to no stop. If this is not the case, then our stop code will be equal to stop and the loop will terminate. Now at the very end of a while loop, we must increment I by 1, and should I surpass our maximum iteration, and this will break one of our conditions in our while loop, therefore breaking the entire loop. Okay, now we are done with our while loop. I will now delete all my indents and indent by 1, so I am outside the while loop but still inside the function. Now we must build our table to display by combining all of our tables. We can do this by setting T2 equal to a list comprehension with a nested list. And in here our first column will be I plus 1, our second column will be our A, third column will be B, the next column will be xi, and the next column will be f at A, and then f at B, and then f at xi, and then our error table, and finally our error note table. Step outside our nested list, and our for clause will be for I in range of the length of x table. Now we must convert this list into a panda data frame. We can do this by saying t equals pd.dataframe, passing the value t2, then columns, which will be our column headers, which the first one will be iteration, the second will be A, B, x underscore I, f at A, f at B, f at x underscore I, er, and error note. Now we have our data frame, we can go ahead and display t. Here we have the entire code for our false position function. Now we will test our function. We can start by declaring our function f at x to return numpy.sign of 5 times x plus numpy.cos of 2 times x. Now call our function false position and pass in the value f, negative 0.6 for A, negative 0.5 for B, 100 for the maximum number of iterations, and 0.001 for our stopping error. Let's go ahead and run that. And here we get our table.